Good morning, dear students. Let us start today's class about the various practice questions for ozonalysis on 17th February 2021. Let me read the question for you. An alkane A on ozonalysis gives a mixture of ethanol and pentane 3-on. Write the structure of IUPAC name, structure and IUPAC name of A. So here we have A. On ozonalysis, it gives ozonide of A, and on the reaction with zinc and water, it gives ethanol and pentane 3-on. We can easily write the structure of pentane 3-on and ethanol, and from the structure of products, we can write the structure of ozonide. So you can see that I have written the structure of ozonide. This is ozonide of A. This ozonide, when it reacts, ozonide is produced when the reactant A reacts with ozone. So from the structure of ozonide A, we can see that there are two carbons where they have the double bond between them. So the double bond is present between the second carbon and the third carbon. This is first carbon, second carbon, third carbon, fourth carbon, and fifth carbon. On third carbon, we have ethyl group present, and thus from the structure of ozonide, we can write the structure of A, and the structure of A is CH3 bond CH, double bond C, CH2, CH3, and on the third carbon, we have ethyl group CH2, CH3 is present, and thus finally we have the structure of A as a 3-ethyl pent-2-ene. So it's quite easy for you, my dear students, to understand this. Now we'll practice one few more questions. So let's move forward and write the question for you, my dear students. An alkene A contains an alkene A contains 3 C single bond C, 8 C single bond H, sigma bonds, and 1 C single bond C pi bond, and 1 C single bond C pi bond. A on ozonalysis, A on ozonalysis, give 2 moles of an aldehyde of molar mass 44U. Write the IUPAC name of A. Write the IUPAC name of A. So first, let us answer this question. Before answering the question, my dear students, first let us pay attention to the ozonalysis reaction. So here what happens, we have A on ozonalysis, so A plus O3, we have the reaction known as ozonalysis, and due to this ozonalysis, give 2 moles of aldehyde. So first we'll get the ozonide of A, and then from the reaction with zinc and H2O, we'll get 2 moles of aldehyde with the molar mass 44U. 2 moles of aldehyde, molar mass is equal to 44U. So this is what it happens. we need to write the IUPAC name of A. So here we need to write the IUPAC name of A. Now, when we look at the various aldehydes, let us start. See, if we write the homologous series of aldehydes, homologous series of the aldehyde, the first member is HCHO, which is nothing but CH2O, and for that molecular mass would be, CH2O, that is 12 plus 2 plus 16, that is 2 plus 2 4 plus 6, 10 1 carried, 1 plus 1 2 plus 1 3. Now if you look into the second one, that is your CH3CHO, we can write it as a C2H4O, and for that we can write the molecular weight is equal to C2, that is 24 plus 4 plus 16, that is 6 plus 4 10 plus 4 14, 1 carried, 1 plus 1 2 plus 2 4, 44 gram per mole or 44 U. That means the 2 moles of aldehyde of molar mass 44 U that we get is nothing but your acetaldehyde, or it can be the ethanol. So the product what you get is either ethanol or acetaldehyde. Now from the product, my dear students, we can write the structure of ozonide. So let us write the structure of ethanol first. We have CH3C, double bond O and H. The another mole is also there of ethanol. So we can write CH3 and H. Thus, my dear students, this is what we can write it for. So we can easily now write the structure of ozonide. So the ozonide what we may have is CH3, then C, then H. Then you can see that we have 3 oxygen atoms gives us the ozonide, and here we have CH3 and H. This ozonide cleaves in this manner to gives us the 2 moles of ethanol. And from that, my dear students, we can easily write the structure of A. So what could be the structure of A? That we can see that this is the number 1 carbon, number 2 carbon, number 3 carbon, and number 4 carbon, and there is double bond between the second carbon and third carbon. So we can write the structure of A. Structure of A as follow. So here we have the structure of A, my dear students, that is CH3, then we have CH, double bond CH and CH3. The name of this compound is butene or 2-butene. Thus we can write the answer for these questions. So my dear students, if you have any doubt, you can ask me. Okay, then let's move forward and understand the next question, my dear students. Now we have the question here in this manner. Let me write the question for you. Propanol and pentane 3-on propanol and pentane 3-on propanol and pentane 3-on are the ozonolysis product of an alkene. Are the ozonolysis product of an alkene. What is the structural formula of the alkene? What is the structural formula of an alkene. So here, my dear students, we can easily write the answer. Here we have the answer. Here what we can see here, if we really understand the question, we'll realize that we have an alkene. This alkene, when it reacts with the ozone, it gives us the ozonide. And this ozonide, on reaction with zinc and water, it gives us the two products. What are these two products? Propanol and we get pentane three on. Now let me write the structures for this products, my dear students. So propanol is, generally we write it CH3, CH2, CHO. Pentane 3 on is CH3, CH2, C, double bond O, CH2 and CH3. So if you write it in the form of the product in a different structure, we can write for pentane 3 on, both the side it has got CH2, CH3, and for propanol, my dear students, we can write it as a C double bond O, and then we have CH2 and CH3, and here we have H. So from this we can easily identify that these are the carbon number 1, 2, 3, 4, 5 and 6, and there is a double bond in the alkene between the carbon number 3 and carbon number 4. From this we can easily write the structure of ozonide. So let us write the structure of ozonide, my dear students. This ozonide would be in this form. We have CH3, then we have CH2 that is bonded to a carbon. This carbon undergoes the reaction with ozone to form ozonide, and both the side we have CH2, CH3, here even CH2, CH3, and here we have H, and this ozonide undergoes the cleavage in this form to give us the product. And from this, my dear students, we can write the structure of alkene, and the structure of alkene is as simple as this. We have CH3, then we have CH2, and there, see, first, second, third carbon, fourth carbon, fifth carbon and sixth carbon. So there is a double bond between the third carbon and fourth carbon. Fourth carbon has got this ethyl group as a branch, CH2, CH3, and here even CH2 and CH3. We can give numbering to the various carbons as 1, 2, 3, 4, 5, and 6. So it's a 4, 1, 2, 3. If we give numbering this way, 1, 2, 3, 4, 5, 6. So here the double bond is present on either third carbon or fourth carbon, but you can see that the branch is also present on third carbon. So this kind of numbering is correct. This kind of numbering is proven to be wrong, and thus we can give the name of this compound as 3-ethyl 6 carbon. So we can write hex, and then we have 3-in. So this is how we can write the structure as well as the structural formula of the alkene. That is what you can see here, and we can even write the IUPAC name. I hope, my dear students, you have understood it well. If you have any doubt, you can ask me. See, my dear students, if you do not reply, I'll understand that you have understood it well, or if you have any doubt, you can ask. Now let's move forward, my dear students, and let me explain the rearrangement reaction. So dear students, we have studied that order of stability for number 1, carbocation is tertiary is greater than secondary is greater than primary is greater than methyl carbocation. Same way, my dear student, we can write the same manner that stability order for free radicals is, tertiary is greater than secondary is greater than primary is greater than methyl free radical. The order we have written on the basis of the hyperconjugation. This order can be explained using hyperconjugation. Now, my dear students, suppose in a reaction, suppose during reaction we get a carbocation which is primary. So, if we write this structure, my dear students, instead of doing this, let us write the structure of this carbocation. CH3, CH2, CH2 and a positive charge. Now here, my dear students, what happens into this, that this positive charge moves. This is first carbon, this is second carbon, this is third carbon. Here, 1, 2, H shift takes place. So this hydrogen moves from second carbon to the first carbon, and we finally get CH3, then we have CH, this carbon get positive charge, and we get CH3. This is what it happens, and here we have the primary carbocation which is converted into secondary carbocation. Same thing we can understand for the free radicals even, my dear students, that if we have a free radical obtained in this manner, which is primary free radical, then my dear students, there will be 1, 2 H shift, and here this hydrogen goes to this carbon, and finally we get secondary free radical. And this is what we can write the structure in this manner. You can see that the first carbon, this is carbon 1, 2 and 3, receives a hydrogen from the second carbon, and here we get a free radical. present on the second carbon, and that is why it is the secondary free radical. So this is how, my dear students, we can understand the rearrangement reaction. There is one more example I would like to share with you for this rearrangement reaction, my dear students. So let's move forward and understand this example so that you can understand it well. Suppose we have a compound CH3, 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 then we have CH2Cl. This compound is let us give name to this compound, my dear students. Here we have first carbon, second carbon, and third carbon, and that gives us the name. Let us give the name. It's a 1-chloro 2,2-dimethyl propane. So we'll call it 1-chloro 2,2 dimethyl propane. When this compound reacts with OH minus, dear students, we get this product. We can say we have aqueous KOH with us, or we can write it as a KOH aqueous. We'll get this product. And that is what it is. We can give it a name 1, 2, 3, and 4, and we can give the name 2-hydroxy 2-methyl butane, or we can say 2-methyl but 2. It is right, 2-methyl 2-butanol. Let us not write the capital B here. 2-butanol. So this is how, my dear students, we write the name. Now let us see what happens during the mechanism of this. And here we have the reaction of rearrangement. So first of all, what happens that our this compound CH3, again we have CH3, this CH2, and then we have Cl. So the 2 electrons present on this bond, they goes on chlorine, and we get the carbocation. And the carbocation, what we are going to get is CH3C, CH3, CH3, CH2 plus, and we get Cl minus. Or let us write it Cl minus minus here, so that we can move forward in a different manner. So we will have minus Cl minus. So we'll get this carbocation. When we look at the carbocation, we realize that this carbon is directly bonded to only one carbon, and that is why it is primary carbocation. Now, my dear students, here we will get 1,2-methyl shift. Here we will get 1,2-methyl shift. This is also the example of the rearrangement reaction. So here, my dear students, the rearrangement takes place, and this methyl group that is bonded to the carbon, this goes to combine with this particular carbon. So here we get 1,2-methyl shift. As we get this 1,2-methyl shift, my dear students, 1, 2, and 3, the methyl group from the second carbon goes to the first carbon, and we get the final product. Let us see what is the final product that we get, and that is what we have as a CH3C, CH3, CH2 and CH3, and we get a carbocation, which is a tertiary carbocation. This tertiary carbocation, which is more stable, this tertiary carbocation CH3, CH3, CH2, CH3 plus undergoes the reaction with OH minus to gives us the final product CH3, CH3, CH2, CH3OH as a final product. And this is how, my dear student, we understand the mechanism of these particular reactions. So I hope, my dear students, you have enjoyed the class. Now, if you have any doubt, you can ask me. Dear students, if you have any doubt, you can ask me. I hope you have enjoyed the class. Wish you happy learning.